I am a software architect by trade, and one of the more important aspects of software development would be code review. And it's a way for team to share their knowledge, collaborate with each other. And with that, if you still don't have a code review guideline for your team, let me share to you 10 easy to implement review guidelines that will make everyone's code more readable and more maintainable. Okay, before we start, rule 0. Don't be a jerk. Always remember you are reviewing the code and not the coder. Always empathize with them and phrase your word with respect. With this, you will avoid any friction whatsoever when giving out your very own comments on your code reviews. Okay, guideline number 1 would be naming conventions. Each technology would have its very own naming convention. You don't have to reinvent the wheel. A lot of technologies would have it on the internet. You can just simply search them. Like for example, this one is on C Sharp and it is very well documented. The next one I want to show to you is nesting. Now, what happens is I have read something that the complexity of the code, whatever language it is, often depends on how many tabs your code has. And one of the culprits for this would be nesting. And as you can see, if you have a lot of if else, it is something that is very hard to read. One way to simplify this is by inverting the logical operators that you have. For example, here, if you have this, if member has proxy access, which is a boolean, you can simply make it a or reverse it into if something is equals false. By doing this, you are reducing all of the nesting of if else, and what more importantly is the exception or the thing that is being put at the bottom at the else, it is now right next to it. Okay, the third one that I would like to share is what I call fail early. Now, as you can see in this example, you have a method accepting ID and message, and it has two submethods, get members, send email. Now, the thing is, for example, here on the ID, it is being passed on one method, two methods down, and that is when the ID is being evaluated. Now, the main problem with this is that there are several codes that have run already before you would have known that an error would be occurring. One way to fix this is that you evaluate things as early as possible. So, for example, on this one, because it's just a nullability and you don't need any extra processing to validate or evaluate this variable, you evaluate it at once. So that is what I call fail early. You try to evaluate processes or variables as early as you can. The fourth one would be check for ambiguity. Now, this code seems good enough, right? You have a list of country and you have a method called check proxy access. Now, to avoid ambiguity, and the main problem is if I am not the original coder for this, I wouldn't have known what the country list is for. And the next is the check proxy access. What does the boolean return means? What is the true or false signifies on this one? And you can easily fix it by adding additional details on the name. As you can see here, instead of just saying country, you say country with proxy access, and it makes the code a lot more readable and understandable. The same thing with the method. Is proxy access available? It instantly answers the question of true or false on this case. So, is proxy access available? Yes. No, no. Without misunderstanding whatever the method is. The next that I would like to discuss would be commenting, because there are a lot of developers that doesn't know when to add or when to stop adding comments. Like for example on this one, you can see that you already have a very descriptive method on what it does, and you don't have to put a comment on this. The same with this one, variable for merge config. The name of the variable itself is very descriptive. Now, the main rule of thumb that I would like to use is that if it takes you a minute to understand what the code or what the line is doing, that's when you put a comment on it. Like for example, on formulas, on logics that you're trying to implement. The same with when you are doing something that is out of the ordinary or out of the norm when it comes to the set of codes that you have. So in this one, as you can see, let's just remove the redundant comments that we have that is just saying what is already descriptive in the code. And for example, this is something that is really out of the norm, and sometimes when you try to check the code or read the code, you will say, why is this being done, type of thing. The same with here. This is a very long logic that it has, and you cannot just understand it when you first see this code, and that's when you have to put comments in it. Now, the next thing I would like to discuss is logging. Okay, so there are three types of or levels of logging. First is error, which shows you whatever error is happening in your code. Second would be information. So every time you put your logging at an information level, it will show you the errors and the information. And lastly, the debug level, which shows you the debug, the information, and the error logs that you have put in your code. So, now, what is the difference between information and debug? Now, I would explain to the developers or my teammates is that information is something that you put if you want to check that your code is running correctly. And debug is something that you put to add additional details for you to investigate why your code is failing. Now, as you can see here, you have this main one, the main process, for example, and you have here all of the steps that are happening. And if you have information only level logging, you can see that yes, the process have successfully happened. But if for some reason on production your code is failing, that is when you put it on a level down, which is the debug mode. And with that, you can see what are the things that are happening on the submethods that are being called on your main method. And that is the use of different types of levels of logging. Now, we are on our seventh one, and this is what I call no catch logic. Now, it is very understandable that, or a good practice, that you put a try catch on lines that you know that will fail sometimes, okay, and you need to do something with it. And as you can see here, this is a sample of sending an email that if the email, for example, the request, something went wrong, you just retry it. But if the server, for example, is down, you report server failure. The problem with try catch is that this whole process that is happening is put inside a temporary space in the memory. And eventually, if you don't free up that memory, it will cause or it will cost enough resources that your server will slow down. And that's the reason why you try to free up whatever temporary memory your try catch is consuming. So what happens is, or a fix that you can do for this is that you just put variable flags inside those try catch or the catch blocks that you have. For example, in this one, you just put a flag of network error or network failure, and you do the additional processing outside the try catch. By doing this, you free up whatever temporary memory try catch code is currently holding, and then you are free to do whatever processing that you have here. Now, the eighth one would be a lot more easier, and that is repeating logic. As you can see here, we have several repeating logic that you can do, and sometimes the main rule is if it is being done more than two, you can extract it into an internal method and just use that. And that is simply what we did here on the fix. So instead of doing this line of code over and over again, we just extract it and we just reuse it here. Now, the ninth one is what I would like to call magic value. And this is a good example of this. Normally, it happens with the formulas that you have or like process value that you have. But on here, as you can see, we got this method, compute net profit, which is this calculation, gross profit minus gross profit times 0.3. The magic value here would be 0.3. And for someone who doesn't code this originally and wouldn't know what the formula is, 0.3 is a little ambiguous. And the way that we can fix it is that whenever we have this type of magic value, we put it on a constant. And as you can see here, I put it on a constant named government tax, which is more readable, understandable on the code. And when you read the actual computation, you can see that yes, it is gross profit minus gross profit times government tax. Okay, the last one would be what I would like to call global side effect. And let's check it out. So we have our main method being called every time my page is load, and we have a get member details here. Inside that sub method, we get the member details, we deserialize it, and what happens is we store the variable on a session. Okay, the main problem on this one is that this session GUID is something that you can use globally in the whole application. And if it is inside this method, it will be hard for you to debug where it changed. You have to go several methods down in order for you to investigate why the change is happening. A simple fix on this is that every time you are changing a global variables like this one, a session, you bubble it up. Okay, you don't change this type of global variables inside a sub method. You change it outside of that sub method or on the method that is calling it. For example, on this one, by doing so, you are reducing the number of levels that you need to debug, that you need to step through when you are investigating why a certain global variable is changing. With that, I hope I have given you 10 very, very easy to implement coding guidelines if you still haven't have any type of code review for your team. If you're interested in other software development techniques, be sure to subscribe here on Hakista TV. Till next time, my fellow Hakista.